Have you ever wondered what happens when time itself fades, stars exhaust their fuel, and matter dissolves into the void? Today, we embark on a journey across trillions of years to uncover the ultimate fate of our universe. We begin in a vibrant cosmos, but look closer, hidden forces, gravity, dark energy, and entropy, are steering us toward an inevitable conclusion. We will explore the Big Freeze, where galaxies drift into eternal, absolute silence. We will confront the terrifying Big Rip, where spacetime itself is shredded at the atomic level. Yet, is this truly the end? Or is every death merely a catalyst for rebirth? Could our universe be a single breath in an endless cycle of big crunches and big bounces within a vast multiverse? We will challenge the limits of physics to uncover why our world is so fine-tuned for life and what lies beyond the dark sector. Buckle up, we are venturing beyond time to witness the cosmic finale. The story of our existence begins not with a sound, but with an unfathomable expansion. About 13.8 billion years ago, the universe was a point of infinite density and heat. It was not an explosion in space, but the sudden, rapid inflation of space itself. This is the cornerstone of our understanding, yet it remains the most profound mystery. As we gaze into the deepest reaches of the cosmos, we see galaxies retreating from us at breathtaking speeds. For a long time, scientists believed gravity would eventually pull everything back together. But in the late 1990s, observations of distant supernovae shattered that expectation. The expansion is not slowing down, it is accelerating. A mysterious, invisible force, which we call dark energy, is pushing the fabric of reality apart. This realization has turned our understanding of the universe's fate on its head. If gravity is the architect of the cosmos, dark energy is its reckless driver. We are living in a temporary cosmic spring, where stars shine brightly and galaxies dance in organized clusters. But this era of cosmic activity is merely a flickering moment in the vast timeline of eternity. To understand where we are going, we must first accept that the cosmos has an expiration date. The laws of thermodynamics, specifically the concept of entropy, the arrow of time, dictate that everything tends toward disorder. Our journey through the possible endings of the universe is not a search for despair, but an exploration of the fundamental laws that govern the birth, life, and inevitable decline of every structure we know. We are about to witness the ultimate destiny of existence, written in the cold, unyielding language of physics. As we peel back the layers of reality, we find that the void is not empty, and the silence of space hides the most violent transformations imaginable. We are merely the observers of a play that started billions of years ago, and we are now approaching the final act. To understand how the universe might end, we must master the forces that define its present shape. Beneath the surface of the stars lies an invisible framework, the cosmic web. The visible matter, everything we see, accounts for only a tiny fraction of the universe's total density. The rest is dominated by two elusive entities, dark matter and dark energy. Dark matter acts as the invisible scaffolding, providing the gravitational glue that prevents galaxies from tearing apart. Without its mysterious presence, galaxies would simply scatter into the void. Imagine a city where buildings are held together by unseen, indestructible cables. That is the role of dark matter. Yet, it does not interact with light. It is a ghost, detectable only through its gravitational influence. But if dark matter is the glue, dark energy is the opposing force, a constant pressure pushing outward against the fabric of spacetime. While dark matter pulls inward, trying to condense the universe, dark energy acts as a repulsive force, accelerating the expansion of space itself. This is a delicate balance, a high-stakes tug-of-war that has lasted for billions of years. Our understanding of the universe's fate depends entirely on which of these forces wins. As the distance between galaxies grows, the influence of dark matter becomes diluted, leaving more room for dark energy to dominate. This shifting power dynamic is setting the stage for one of three terrifying, yet mathematically plausible, final scenarios. The invisible engine of the universe is changing gears, and the direction it takes will dictate whether our future is one of frozen isolation, a sudden collapse, or a violent, shredded end to reality itself. The most widely accepted prediction for our universe's fate is the Big Freeze, a slow, lingering transition into eternal darkness. As dark energy continues to accelerate the expansion of space, galaxies will drift further apart until they are no longer visible to one another. The sky will gradually darken as the stars exhaust their nuclear fuel. Once the last generation of red dwarfs burns out, no new stars will form. The universe will enter the era of degeneracy. Atoms themselves may begin to decay, and black holes will be the only remaining anchors of structure, slowly evaporating through Hawking radiation. Eventually, even they will vanish in a final burst of gamma rays. The universe will reach a state of maximum entropy, where the temperature is uniform and indistinguishable from absolute zero. This is not a sudden catastrophe, but a cold, quiet descent into a featureless void. In this state, motion, energy, and time effectively lose all meaning, as there are no processes left to mark the passage of existence. The cosmos will become a vast, empty graveyard, a cold expanse where not a single spark of light will ever ignite again. It is a haunting vision of total equilibrium, a final, frozen silence that persists forever. While the Big Freeze suggests a slow fading, the Big Crunch offers a much more dramatic alternative. This theory posits that if the density of matter in the universe is high enough, the current expansion will eventually halt. Gravity, the force that once gathered dust into stars, will finally overpower the outward push of dark energy. Like a ball thrown into the air, the universe will stop expanding and begin a slow, inevitable contraction. As galaxies reverse their course, they will head toward one another, leading to a crowded, hotter cosmos. Stars will merge, and the background radiation will shift from cold to searing heat. The sky will blaze with the light of compressed matter, and the universe will shrink toward a singular, infinitely dense point, a mirror image of the Big Bang. This event, the Big Crunch, would effectively erase the history of time and space. Some theorists propose that this is not truly an end, but rather a big bounce, where the collapse triggers another expansion, creating a cyclical universe that repeats forever. In this scenario, our existence is just one of countless iterations in a cosmic breathing process, where space expands and contracts in an infinite loop of birth and destruction. It is a concept that challenges our perception of linear time and suggests that the end may simply be the beginning of something entirely new, forever recycling the matter and energy that define the fabric of existence. If dark energy is not a constant but grows stronger over time, we face a far more violent destiny known as the Big Rip. In this scenario, the accelerating expansion of space becomes so powerful that it overcomes all other fundamental forces. It begins subtly, as galaxies are torn away from their clusters, making the night sky emptier. As time progresses, the expansion begins to dismantle structures on smaller scales. First, gravity's hold on galaxies fails, causing them to shred into clouds of stars. Then, it overcomes the gravitational binding of solar systems, tearing planets away from their host stars. The force becomes so intense that it affects the atomic level, ripping stars and planets into fragments. In the final moments, the expansion becomes infinite, tearing through the electromagnetic and nuclear forces that hold atoms together. Planets, then stars, then atoms themselves are shredded into their subatomic components. Space itself is stretched until it can no longer support the existence of matter. It is a catastrophic, unstoppable surge of energy that tears the very fabric of the cosmos apart, leaving nothing but an unrecognizable, expanding void. Unlike the cold descent of the Big Freeze, the Big Rip is a dynamic, explosive conclusion that ends with a final, violent unraveling of all material existence. Perhaps the most terrifying possibility is the vacuum decay, a process sometimes called the Big Slurp. This theory rests on the idea that our universe might exist in a false vacuum, a state that is stable but not the lowest possible energy state. Like a ball perched on a hill, our universe could potentially roll down to a more stable, lower energy state at any moment. This transition would create a bubble of new reality, expanding outward at the speed of light. Inside this bubble, the fundamental constants of physics would be entirely different, making chemistry, stars, and life as we know it impossible. Because this bubble travels at the speed of light, we would never see it coming. It would simply arrive, and reality would cease to exist instantly. This isn't a slow entropy or a grand ripping apart, it is a fundamental reformatting of the universe's core rules. If a bubble of true vacuum were to form anywhere in the cosmos, the resulting collapse would consume the entire universe in a flash. The laws of nature would be rewritten, and the structures that make up our existence would be annihilated before the information of the event could even reach us. It is the ultimate cosmic lottery, a silent, instantaneous switch that could flip the universe from a life-sustaining environment to a sterile, empty state without warning. Amidst these cosmic catastrophes, one must ask, what becomes of us? As the universe evolves toward its final act, our own journey remains a fleeting flicker of consciousness. Even if we master the stars and colonize distant galaxies, we are ultimately bound by the physical limits of our universe. Whether we face the creeping cold of the Big Freeze, the crushing collapse of the Big Crunch, or the sudden violence of vacuum decay, our survival hinges on our ability to transcend our biological origins. Perhaps future civilizations will learn to harvest energy from black holes, or even manipulate the dark energy that drives our expansion. Yet, even with godlike technology, we remain players in a theater whose curtains are destined to close. The irony of our existence is that we have emerged in a rare era, Goldilocks time, where the universe is active, luminous, and filled with the very elements necessary for life. As the cosmos approaches its twilight, the challenges of survival will shift from mere resource scarcity to the survival of the laws of physics themselves. We are the universe's way of experiencing itself, the rare observers capable of documenting the story of our own extinction. This realization is not meant to bring despair, but rather to instill a sense of profound purpose. We exist to bear witness, to record the symphony of existence before the final silence descends. Our search for a future is essentially a quest to preserve the legacy of consciousness, ensuring that no matter the final destiny of the cosmos, the fact that we once understood it remains inscribed in the archives of time. As we reach the final horizon of our inquiry, we are left with the most profound question of all: does the end of the universe represent a true conclusion, or is it merely a chapter in a much larger, unseen narrative? Science provides us with the equations and the data, but it often leaves us yearning for meaning. Whether the cosmos drifts into the infinite silence of the Big Freeze, re-emerges from the ashes of a Big Crunch, or vanishes in the blink of an eye during a vacuum decay, the reality remains that we are part of something unimaginably vast. Our quest to understand the end is, in essence, an attempt to understand ourselves. We are biological machines, built from the remnants of dying stars, capable of contemplating the very forces that will eventually dismantle us. This capacity for wonder and inquiry is our greatest triumph. Regardless of what the final act holds, the fact that we have stood upon this tiny, fragile planet and dared to map the edges of eternity is a testament to the resilience of curiosity. The story of the universe is a story written in light, gravity, and mystery, and as long as there is an observer to read it, the universe is never truly lost. We find our meaning not in the longevity of our structures, but in the intensity of our search for truth. As the curtain falls on the cosmic stage, we leave behind a record that we were here, we looked up, and we understood. The mystery continues, and perhaps, that is the most beautiful answer we could ever hope to find. The cosmos is a cycle of infinite possibilities, from the silent birth of stars to the final decay of spacetime. Exploring the universe through the lens of science reminds us of our unique place in this vast reality. If this journey through the multiverse sparked your curiosity, please hit the like button, share this vision with fellow explorers, and subscribe to join our future adventures into the deepest mysteries of space. Stay curious.